Welcome everybody. You're watching Mr. Fugu Data Science. Today we're going to look into scaling data with limited memory, such as when you're working off your own machine like a laptop. We have a few considerations we should think about. Loading data into memory can be really tricky. It's pretty problematic, and if you have a large data set, you have to figure out techniques to efficiently process your data. We're not going to do any coding today. I want to give you some ideas to think about that'll help you on your journey when you have this come up in the future. Pandas will load your data into memory, which could cause you a lot of issues later on, especially when you use some of the operations which can drastically explode the amount of memory usage you have. You should pay attention to your data when making intermediate copies, which will ultimately slow you down in processing. We can do a few things. You can, if you have a budget and don't care, you can buy a faster machine or rent access from cloud computing, or you could just throw a bunch of memory at your machine if it allows you, because of course running something in memory is a lot better than throwing it onto disk. Have you ever had an issue where your data is pretty big and you just wondered, well, where did all this memory go? I mean, really, you have a small file, maybe less than a gigabyte, and while you're doing some manipulations, it all of a sudden becomes a few gigabytes. And you think to yourself, well, what's really going on here? Well, there's a few workarounds that we'll introduce today that could help you out, but won't solve all of your problems. I left a lot of citations and links here for anyone who downloads or wants to view this code to help them get a better understanding of how to approach situations like this that will come up in day-to-day real-world scenarios. Let's look at a good recommendation. One of the things you should be aware of is something called a profiler. It's not like profiling somebody for a job application or walking down the street and giving them the business. This is investigating memory usage. Some of the things that you can do using your own machine, which are pretty useful, would be on a Mac. Consider looking at the get R usage, and then there's a function that I have right here, which is the R usage _ self. In Windows, you could look at something called PS util. What you want to do in writing a profiling function or using a module is to think about what is it really doing. Well, you're not actually benchmarking. This is a little bit different because you're actually considering the time of certain operations while running your script. This is evaluating your entire program. It's not just doing a benchmark. If that's something you want to do, look into something such as time it in Python. There's other versions. Just look into that. The two types of profilings that we can deal with are the deterministic and the statistical. When you deal with the deterministic, while you may have something that produces very accurate results, it creates a burden for your overhead, which then decreases your performance. Think about using this when you're running some small functions, okay? Less accurate but fewer overhead issues would be considering a statistical model for your profiler. You have the availability of looking into, well, what functions are actually calling each other? And you could get it printed off in a graph format. You could look into this gprof2 dot, which is a script that will print out basically a plot showing you what functions are calling each other. It's really cool. And I left a link that you should probably check out, as well as some other tools such as vprof, pyflame, and stack impact. Now, these kind of tools are just ways for you to do workarounds with certain situations. Remember, not everything you see will solve every situation. Like when I solve JSON parsing problems for people, you should understand like it's a case-by-case scenario. There's tools that you use that help you work around your problems. We can next consider modeling and estimating our memory usage. What if you're stuck in a situation and you're unable to model or even estimate your data? Like, what do you even do there, right? In that case, you need to try a smaller model, possibly doing sampling or reducing the number of inputs. But in doing this, you need to be cautious, because if you're sampling too much, you can lose your information, and you don't want that. So be careful. From there, you can try to extrapolate your data to get a general idea of how much memory you you may be using. And one thing to note, there are differences if you come across the terminology of peak resident memory versus peak memory usage. Look into those if you're curious or if they come up. When you're managing your resources locally, you need to think about something which is overlooked but a great resource. Garbage collection. Not like the man who comes once a week to go take all your undesirables. No, this is something that's done in your computer, but you could have, for instance, the Python import GC module, which could take care of garbage cleanup and allow you to monitor certain functions or deletions, creations of objects that you may or may not be using anymore, and get rid of those to free up your memory usage. For instance, if you're looking for something that's an in real-time monitoring using your command line, for Mac, look at the htop function. PC, look into psutil. The use case for these would be monitoring your memory usage, processor, or swap usage, for example. Something that's really convenient and might be overlooked is the fact that you could change your data types. For instance, when you're importing a file such as a CSV and you always encounter object, and you're just like, okay, I need to convert this into a date time formatting. That right there is going to reduce your memory usage. Maybe you need to convert it into an int and it's a 32 instead of a 64 or something like this, right? Looking at stuff like that, or large strings, can become an issue which is hogging up your memory. If you have another situation where you have some data but it might be too large to run at once, consider splitting it up into chunks and either doing your analysis or getting a rough estimation of whatever you're doing. That can help you out. Something that's very useful that rolls over from the database world would be indexing. Consider taking subsets of your data if you can, which may help you out, and compression. There's two forms of compression. You have lossless and lossy. And you have to be very careful because you can compress your data, but you may lose some of the information. This Kaggle paper right here, or posting, is pretty useful and really interesting. So check it out. But let's think about a few libraries that we can use to also offload some of our resources if we're just in a scenario where one single machine is just not enough. Let's think about parallel computing. You have two options that you can investigate on your own called Dask, D-A-S-K, and VAEX. However it's pronounced, who knows, but V-A-E-X. If you're scaling for clusters, you could look into Dask, you could look into Hadoop, things like this. This will help you just do scaling of models, whereas the VAEX or VAEX, whatever it is, that's working on a single machine with your data. You should learn what their limitations are, because there are some. Converting your file type. This is something that makes a big deal. When I was in college and I would see my stats professor always throwing everything into a pickle file, I had no dang clue what was going on. But when I read this, it makes more sense. When you're looking into storing your data, we can look into two things, a pickle file and Parquet files. The pickle file is used to store everything in a byte format. And this is where you have the terms serialize and deserialize. So you're just throwing it into that format and storing it, or are you converting it back into the original format? The wonderful thing about the pickle file is it could get converted back into a Python readable form, which is great for, humans. But you have to be careful, because when you're going in the reverse, you may have an explosion of your data, because while you're compressing your data using the pickle file, when you go in the reverse and put it back into Python, now you might end up having this big file that may give you an out-of-memory error. So there's tools called pickle tools, which you should look into, which is pretty cool, that helps you deal with this and manage your memory so you don't end up crashing your machine. A pickle file is used to transfer data in a manageable way in the real world. It easily reads and stores information as well as data types. This is really important. It stores your data types, unlike your good old friend, the CSV file that we're always so used to playing around with. But there's one thing you need to be careful. This is a big old flashing sign right in your face. Do not unpickle a file where you don't know where its source came from. Don't open that junk. You could end up getting yourself in a world of hurt. Background motivation. File formats such as JSON, CSV, or databases like Postgres, they use row-wise storing. You don't always need this. You don't always want this. When would you not want this? Well, you have some big old files in the gigabyte plus range, and you're doing read and write operations on a single machine. This isn't exactly efficient. Working with columns, on the other hand, calling your data selectively will help you save your memory. If you could flatten your columns problems with redundant information, you now are efficiently managing your memory. The good old Parquet file. It helps with storage size. This is a good option if you want to support nested data, save data types, gives you faster reads, used by Hadoop, great for running queries on big data and the gigabyte plus, for each file, and supports various encodings. 3 ways Parquet files can help you. It does columnar storage, which is built for efficiency. You have the ability for columnar compression, which allows you to use the different codecs for different files, which will aid you in your speedups. And then you have data partitioning. And this is splitting unique values and creating a tree-like structure. Just think of key value pairs. Reading data such as a CSV or JSON row-wise can give you some inherent problems with larger files when you're working iteratively. Therefore, look into a columnar approach. Let's look at this little simple example I have right here with my made-up markup table. Let's look at our little Pokemon guys. If you notice the game number right here, they're all the same for this column. Well, if we're working with row-wise CSV files or we're working with JSON or running Postgres, if we're to find this redundant data, we have to scan this row by row by row, row by row. That's kind of time consuming to find out what data we have when, if we were working column-wise, we'd be able to compress this immediately. Let's figure out some other ways to save memory. Changing your data types, I mentioned before. Other ways to save our memory. Let's do a little bit of recap. Remember, data types. Changing those to save your memory. You also want to watch out for the pandas concat. This thing will explode your memory like crazy. So be aware. Go on Stack Overflow, Google it. You'll see what I'm talking about. You start concatenating all these data frames, you start running into some issues later. If you start running out of space, throw in that Parquet file. It's readable to pandas. You should be good to go. Understand that there is a trade-off. All right, let's highlight this. This is readable for pandas. Okay, fine, that's great when you're dealing with limited memory. But there's a trade-off. Time could be the trade-off here. So if you're in a situation where you need to reduce memory, you may have to sacrifice your time. Depending on the task, just be aware of this. Please consider reading some of these files. It'll help you broaden your scope of thinking and give you some other tools that may help you out. They should help you out. Do you need all of the data? This is one thing that comes up quite a bit. We want to maximize the resources we have, but we also want to maximize our time. Well, what can we do about this? Think about dropping some of your columns, come back to our garbage collector friend, or consider doing generator functions. The generator functions are pretty useful because you're not iterating everything at once. You're using a yield statement, and then from there you can iterate one by one through whatever chunk size or function information you have. So it's really cool and efficient. Here's a little throwback to the pandas concat and memory issues if you want to read this to figure out what's going on. And lastly, let's consider some free tools, cloud computing, which sometimes you could get credits, if you're a new person. After that, it could become extremely expensive to prototype. Google Colab's free. That could help you offload some of the memory issues you have. Also could help you run code, while you're connected online. If you don't have your machine and you're working from something that doesn't have all the tools you have hooked up somewhere else. Look into Spark for parallel computing, Dask, or Viax. Now that concludes the video, but I'd like to say, as always, thank you for watching, and please like, share, and subscribe. Sorry I've been gone for a very long time. Just been a crazy year. See you in the next video. Thank you for watching. Bye.